Hi guys, so today we're going over 12.2 integration by substitution. So before we kind of get into the problems, I kind of just wanted to go over some general things, just kind of a quick review on things we've already covered and whatnot. So just as a reminder, we have kind of the three general forms of functions that we have seen thus far for integrals, and they strongly resemble the three forms that we had for derivatives. Now this one is like our reverse power rule in a sense. So we're going to add 1 to the exponent and then divide. And anytime we're doing integration, we need to do our plus c. Okay? And then same as since e to the x, the derivative of that is just itself, it's the same when we're going in the opposite direction. So we're still just going to have e to the x and then our plus c. And then this guy, the only other option we have left is natural log. We need to remember to add in our absolute values. So those are our three functions. Those are kind of what we're going to be referring to even with our substitution. One quick note with this guy here. So, well, I guess technically this guy here. We are only looking at natural log when it's just 1 over x, or x to the negative 1. If it is x to any other power, we use this guy. So only when it's 1 over x, or x to the negative 1, are we going to be looking at natural log. Okay? So one quick thing that I just wanted to note. And then as far as with u substitution, I'm just going to call that u sub, we can rewrite any of these to be the exact same thing, but in terms of some specified u. Okay, and we'll look at what to set u to equal to. And then it's the exact same setup as with x. We get the exact same thing. So it works the exact same way, just substituting in this expression for u. So now that we have kind of that quick review, let's actually look at some problems. So let's look at problems like 13, well, honestly, like 11 through 19. Any of those are really good. So we'll just say those kind of problems, and I'm just going to choose one of them. Let's look at 13. Okay, so we are given integral 5x cubed plus 1 to negative 3 times 15x squared dx. Okay, cool. So remember, the same as with derivatives, all we know are these three functions. That's all we know. That's all we've learned how to do. So anytime we get something that doesn't look like one of these three, we need to rewrite it so that it does. So with this expression here, we have to kind of look at what is more complex in a sense. So what's more complex, this 15x by itself, or this expression that's to a power? Okay, now I'm sure you guys can guess, but whatever is going to be to a power is going to be a little bit more complex. Kind of the same way as with chain rule, you're kind of looking at what was more involved being your outside function. The other thing is, anytime you have an expression that's to a power, you're going to want to use that as your u sub. So we're going to say our u is whatever is with our power. Okay? Now that's step 1 of doing u substitution. The next step is we need to deal with this integration piece. Okay? And to do that, we take the derivative of our u expression. So we get 15x squared. And then we can treat this guy like a fraction and multiply both sides by dx, giving us du equals 15x squared dx. Okay? So now we have that this guy here, that's our u, and our 15x squared times our dx, that's our du. So now we can say that this is equal to u to the negative 3 du. And now we have something that's a lot easier to work with, and we can use one of these three up here, and we'll actually be looking at over here with the u's. Okay, and then we just do our integration as normal. So we'll have u to the negative 3 plus 1 over negative 3 plus 1, and then we can't forget our plus c. Okay, and then u to the negative 2 divided by negative 2 plus c. And our last step always whenever we're doing u substitution is to plug everything back in so we have everything in terms of x. So we get a negative 1/2 5x cubed plus 1, the negative 2 plus c. So if we really wanted to express our answer completely, we would say the integral of 5x cubed plus 1 to the negative 3 times 15x squared dx, that's equal to a negative 1/2 5x cubed plus 1 negative 2 plus c. And it's always good to check your answer using chain rule, just to verify that you do in fact have what you want. Okay, awesome. So that was just one kind of general example, and it also kind of gives you a chance to look at what I was talking about up here, where if it's not a negative 1 exponent, like we have here a negative 3, then you're using that reverse power rule. Okay, awesome. So now let's try another problem. So we can look at, say, problem 16. So there we have integral e to the x cubed, times 3x squared dx. Okay? So in this case, we have something a little bit different going on, where we don't have an exponent like we do up here that's just a numeric value. We have instead an exponent that's a function itself. But think about when we were doing chain rule, oftentimes if you had something that was like e to the x squared plus 2, this exponent right here, that was your inside function. Same thinking applies when you're doing u substitution. You want to kind of think of what's my inside function. If you're looking at what's kind of more complex, and your e to the x cubed, that's more complex, and whatever would be your inside function is your u. So then we can say u is equal to x cubed, okay, because this e to the x cubed, that's what's more complex, that's what's kind of harder about this integral than the 3x squared. That piece is a little bit easier to understand, but this e to the x cubed, that's a little bit more complex. So we want to simplify that guy as much as we can. And then same as before, we want to get rid of that dx and put everything into terms of u. So then we'll just take this derivative and we get du over dx equals 3x squared. Multiply both sides by dx and we get du equals 3x squared dx. And then same as before, this guy right here, that's our u, and then 3x squared times dx, that's our du. So then we can say this is equal to the integral of e to the u du. And then we know what that evaluates to. That's just e to the u is just itself plus c. And then our last step is just to plug back in our u expression and get everything into terms of x again. So we want e to the x cubed, ax squared dx, that equals e to the x cubed plus c. Awesome. So shouldn't be too bad at all. Really just think about it as reversing the chain rule. Okay, so now that we've kind of looked at some of those a little bit more basic problems, let's look at something a little bit harder that's not quite as obvious. So one thing I will note, your quiz today is mainly focused on 12.2a, but in discussion we're going to go through problems from 12.2a and 12.2b just to kind of give you guys a full sense and give me a chance to go over some stuff. So the only real difference between 12.2a and 12.2b, in 12.2a your du always matches perfectly with what you have in the expression. In part B, you'll have to manipulate your du in some way to get it to match correctly. Okay, so let's look at a problem like that. Let's look at problem 32. This isn't exactly a problem that was assigned, but it's similar to other problems that are assigned, and it's covering the same information, so it's still a really good problem to go over because it kind of has a lot of good concepts in it. So you have 3 over 2 minus t dt. Okay, so far we've looked at setting u equal to whatever is in the exponent, like within a power here, like with -3, the u, what was ever inside of that. We also looked at setting u equal to the exponent for e. Now we can look at where we want to set u as the denominator. So those are kind of the three things to look for, whether you have a power, the exponent, or the denominator. Okay, so those are kind of the big three. And I would say go with the hardest, the most complex out of those. And another thing that I mean by most complex is highest power of your variable. So here you have x cubed and you have x squared. X cubed is a higher degree, so that's your more complex term versus your x squared. Same as with up here, you have x cubed, x squared. X cubed is your higher degree, so it's more complex. So same kind of idea. Your 3 that's just a constant. So 2 minus t, that's more complex than 3. Before I do u subs though, I'm going to actually just rewrite this really quick. Oopsies. And I'm going to move that out. So it looks a little bit more like what we've seen before. Okay, now that I have that out of the way, I can do my u substitution. So I want u to be my denominator. And I'm going to skip a step here. I hope that's okay with you guys. The derivative of 2 minus t, that's a -1. So we get -1 times dt for our du. So we get that this denominator, that's our u, and this 1 dt, we only have 1 dt, but in our du, we have a -1 dt. So we want to multiply this du by some number. We can only do a number so that it matches with the information we're given. And we can just multiply this whole thing by a -1, get a negative du equals 1 dt. So now we have that is a negative du. So then we have 3 integral 1 over u times a negative du. And we don't really want that negative in there because it kind of makes things a little bit more confusing. So we can just move that outside of the integral and then get 1 over u du. Now this is an expression that we've seen before. We know how to integrate this. So we can just say that this will be equal to a negative 3 natural log u plus c. We can't forget our plus c. And our last step is to rewrite everything back in terms of our variable, in this case t. So we're going to have a negative 3 natural log absolute value of 2 minus t plus c. Okay? Awesome. The last problem that I wanted to go over is one where it's not super obvious what you should choose for your u. So problems that I'm talking about there are like 67 through 70. Those are those type of problems. So let's go through problem 69, because I think that one's a good one. We have e to the 1 over x divided by x squared dx. Okay, now this is all in the exponent and I want to make that very obvious. Okay, so what on earth do we choose? We have a denominator, we have an exponent, and the power in the denominator is greater than this exponent because that's 1 over x. What on earth do we choose? Well, maybe it might be easier if we actually rewrite this. So let's say e to the x to the negative 1, just rewriting this 1 over x, times x to the negative 2 dx. Okay, so still not really sure because this seems like the higher power. But one thing I'll tell you guys is remember from way back when you were first learning about negative numbers, you have a number line here, here's 0, 1, 2, negative 1, negative 2. Negative 1 is actually greater than negative 2. So this right here is what is, if we're keeping it the same kind of concept, that's our more complex term. Can I put that in quotes? X to the negative 1 is a higher degree than x to the negative 2. Okay? We don't need that guy there, because that's just going to confuse people that just look at the notes. Okay? So now that we know that, x to the negative 1, that's going to be considered our more complex term. So now that we have that, what do we think that we want our u to be? We're going to want it to be our exponent here, because especially now that we've gotten this out of the denominator, we can see that our exponent is more the choice that we want. So we're going to have u equals x to the negative 1. And remember that when we're taking the derivative of x with a negative exponent, we're still subtracting, but we get negative 2. That's another way to verify that we made the right choice, is if whatever we have in our du shows up in some way in our integral times dx. Now here though we have a negative x to the negative 2 dx, and up here we just have x to the negative 2 dx. We're missing that negative, so we can just multiply by it to add it back in, and so we get x to the negative 2 dx. Now this is equal to a negative du, and this is our u. Kind of got a lot of writing and color coding going on here. But now we can say integral e to the u times a negative du. Just pull that negative out of there. It's less ugly. And then we have something that's really, really nice. Plus c. And our last step, as always, is to write everything back in terms of x. So I'm going to write it out the way I was given it. Equals a negative e to the 1 over x plus c. Okay? So I hope that cleared that problem up for some people, if you were looking at it at all. Was one of your notebook problems. So I think that was most of what I wanted to go over today. And I will post these notes online so that you guys can see them. And I'll post this video online as well. But if there are any problems that you guys think of, that you have questions on, you're more than welcome to reach out to me. I will try to get back to you as soon as I can. But otherwise, I would say have a good rest of your day, and good luck on your quiz if you haven't taken it yet.